You can see the little red thing up in the corner, and it's recording. All right, the unit circle. Anybody know what the unit circle is? What's a circle? Okay. Well, you know what's a circle, right?
Yeah.
What's a unit circle mean?
Oh, it's like 1 unit diameter. It's like 1, right?
Some unit means one, but not one diameter, rather one radius. All right, so the unit circle is the circle centered at the origin with a radius of 1. So this is the point 1, 0, 0, 1, -1, 0, and 0, -1. And that's known as the unit circle. The word unit means 1, and that's supposed to be a circle. I've drawn worse circles. All right, so I gave you 4 points on the circle, 1, 0, 0, 1, -1, 0, 0, -1. Can anybody else tell me any other points on this circle? 0, 0, 0 is inside the circle. 0, 0 would be here. I want a point right on the circle. All right, well, what can you tell me about points on the circle? What can you tell me, what's the biggest possible x number and what's the smallest possible x number?
1.
Yeah, the x's have to go in between -1 and +1, don't they? Okay. So give me your favorite x number that's between -1 and +1. 0.2. Which I'm going to write as 1/5. How can I find the y value? What's the equation of that circle? Anybody know the equation of a circle? Anybody know the equation for a circle? It could have h's and k's, except h and k stands for the center. And where's our center? 0, 0. So h and k are both 0. And what's our radius? 1. So what's the general equation of a circle with the h's and the k's? Do you remember? Plus, yeah. So there's the equation for any circle at all, where h and k are the center, in which case h and k are 0 and 0 for us, and then r is the radius. So the equation of our circle that we're working with is x squared plus y squared equals 1. So if I know that x is 1/5, how can I find y? Plug in 1/5 and solve for y. Correct. So I'm going to have 1/5 squared plus y squared equals 1. So y squared is 1 minus 1 over 25, which is 24 over 25. So y is square root. I heard somebody say plus or minus. We get 2 answers, don't we? When we square root both sides, there are 2 answers. Plus or minus the square root of 24 over 25. I'm going to write that as plus or minus square root of 24 over 5, because square root of 25 happens to be a nice number. I could, if I wanted to, simplify my square root of 24. Do I want to? No? Oh yes, I do? I don't? Truthfully, I don't care. When it comes to simplifying square roots, I don't care if you do it. I mean, I would expect you to simplify square root of 25 to be 5. If you want to simplify square root of 24, I don't care if you do it or not. That's my opinion. All right, so notice, if x is 1/5, that actually generates 2 points. So if x is 1/5, that's not very far here. We actually get 2 points on the circle. We get 1/5, comma, square root of 24 over 5. And then we get this one down here, 1/5, negative square root of 24 over 5. So by picking one x number, we actually generate 2 points. Now, what if somebody had said, I want x to be negative 1/5? How would that have changed things? Would it have changed the y at all? No, why not? Because if x is negative 1/5, what happens when I square negative 1/5? I get positive 1/25 again, don't I? So by picking x equals 1/5, I get these 2 points. But at the same time, if x is negative 1/5, the y's are going to be exactly the same again, aren't they? So by picking one x number, I actually quite quickly generate 4 points on the unit circle. Negative 1/5 square root of 24 over 5, and negative 1/5 negative square root of 24 over 5. So there's how you can generate points on the unit circle. You could pick an x number, or you could pick a y number. Really wouldn't matter too much. And you would generate 4 points very quickly. What if, instead of x equals 1/5, I had chose y equals 1/5? How would that change things? What's that? Yeah, if I chose y to be 1/5, what's x going to turn out to be? X would turn out to be that, wouldn't it? So in a sense, by picking x equals 1/5, I generate 4 points. But if I were to plug in y equals 1/5 and solve, I would get this answer for x. So I kind of get 8 points in a sense. I could mark 1, 2, 3, 4 more points where y is 1/5 and x is these numbers. So you can very quickly generate points on the unit circle. All right. Let me draw my unit circle here. Let's say I were to start at this point and I walked all the way around the circle. And I stopped right there. I made one complete revolution. How far would I walk? What would that distance be? It would be the circumference of the circle, wouldn't it? Because I walked right along the edge of the circle. How do you find circumference of a circle? Two pi r? You don't sound confident on that. Yes, all right. Circumference of a circle is 2 pi r. What's area of a circle? Pi r squared. Circumference can also be written as pi times the diameter. How come circumference is also pi times the diameter? 2 times the radius is the diameter. All right, so here's a cheesy way that I was taught many, many years ago to remember these formulas. Cherry pie delicious. Apple pies are too. As I told you, it was cheesy, but it always stuck with me. Cherry pie delicious, apple pies are too. So there's how you remember. That's how I remember those formulas. Anyway, so this arc length we typically call t. So if t is 2 pi, if I go all the way around the circle, if my arc length is 2 pi, what's my terminal point? Where did I end up? What point did I end up at? Starting point, which is 1, 0. So if t equals 2 pi, the terminal point is 1, comma 0. What if my arc length t is only pi? Then I only went halfway around the circle. If t is pi, I've gone halfway around the circle. So what would my terminal point be? Negative 1, comma 0. How about if t is negative pi over 2? My terminal point would be 0, comma negative 1. Why 0, comma negative 1? Because the negative means I went the opposite way. So I went this way, and I only went a quarter of the distance. Questions on that? All right, now there are some other very famous terminal points. Redraw my circle. What if I drew that line right there? That's the line y equals x. If that's the line y equals x, how long is that arc length? Where's pi over 2 is where? Halfway is pi. So pi over 2 is a quarter of the way. Pi over 4 would be, I'm sorry, this is pi. This is pi over 2. So this is half as much as that. That's pi over 4. You're correct. So t would be pi over 4. If t equals pi over 4, what's that terminal point right there? That 45 degrees. Oh, 45 degrees. That has something to do with angles. I haven't talked about angles anywhere yet. There's no angles here. We have arc length.
Would that be our x?
I need the x and the y at that point. That's correct.
So when we plug in the t,
No. T and x are different letters. All right. So we have. Remember what our equation was again? This is x squared plus y squared equals 1. But if I'm right here, what can you tell me about x and y? Y equals x. X and y are exactly the same thing. So I could write this as x squared plus x squared equals 1. Because x and y are exactly the same number on that line. So I get 2x squared equals 1. So x squared is a half. So x is square root of 1/2. And I'm only using the positive square root. How come I'm only using the positive square root? Because I'm over here in quadrant 1. Over here in quadrant 1, x is always a positive number. All right, this is quite often rationalized and written that way, square root of 2 over 2. That's the way you normally see it. Oops, well, you can't see it at all, can you? There you go. If x is the square root of 2 over 2, what's y? It's also the square root of 2 over 2 because they're equal in this case, aren't they? Y is also square root of 2 over 2. So our terminal point right here is square root of 2 over 2, square root of 2 over 2. That's one of our famous ones. This pi over 4, this will come up a lot. We'll see that one. So the terminal point at pi over 4 is square root of 2 over 2, square root of 2 over 2. X and y are equal. Questions on that? All right, some other famous arc lengths, some other famous terminal points that we should be familiar with, and I'm not going to show you where these come from. I'm just going to ask you to believe me. I'm going to draw this one, which is the arc length pi over 6. For the arc length pi over 6, anybody happen to know what the terminal point is? X is square root of 3 over 2, and y is 1/2. Excellent. And another famous arc length is pi over 3. Anybody happen to know the terminal point for pi over 3? Was what? No. If x is square root of 2 over 2, y is also square root of 2 over 2.
Is it reversed or that?
Is reversed of that one. It's 1/2 square root of 3 over 2. All right, so those are some famous ones. And those arc lengths, pi over 6, pi over 3, pi over 4, those will come up a lot in this course. So eventually we'll just memorize all these facts. In fact, starting Friday, start memorizing these things. Questions on that? All right, back to the picture here. Ooh. My circle got flattened on one side there. It's the same picture we had a few minutes ago. So there's my unit circle, and I do the line y equals x again. That gave me my angle t equals pi over, not my angle, my arc length. That's not an angle, that's an arc length. T equals pi over 4. And that has, as a terminal point, square root of 2 over 2, square root of 2 over 2. What if, however, I asked you for that arc length? How far is that? 1 pi? 1 pi, if I went 1 pi would start here and end right there. There's pi. No, I notice when I drew the green one, I started right here. It's hard to see, but I did start there. So I want to know if I start here. Typically, when we measure our arc lengths, we start here and we go around. So this length would be pi. How much is that length? The total distance around is 5 pi over 4. How'd you get 5 pi over 4? Correct. From here to here, that distance is pi. This arc length is exactly the same as that arc length. So this green arc length is pi plus pi over 4, and you get a common denominator, and you add your fractions together, you get 5 pi over 4. What's the terminal point? What are the x and y values right here? Negative root 2 over 2, negative root 2 over 2. So notice, this point is exactly the same as that point, except this one has some negative signs. And there's a name for that. This arc length is called the reference length. And this point is called the reference point. So let me tear this one out because we need this picture here. I'm going to draw another angle, or not an angle, another arc length. I quit calling them angles. We'll eventually see that angles and arc lengths have a lot in common. All right, so there's my unit circle. And I do an arc length of t equals 2 pi over 3. The reference arc length would be from here to get back to the axis. It's usually written as t bar. So to find the reference arc length, you always go to the x-axis. So if this is 2 pi over 3, how much further do I have to go to get down to the axis? Absolutely. All the way to here would be pi. I've already used up 2 pi over 3. So to find my t bar, I take pi minus 2 pi over 3. What's pi minus 2 pi over 3? Pi over 3, correct. She didn't say it out loud, but she mouthed it. I saw her. So my reference arc length is pi over 3. My reference number is pi over 3. So now, what is this terminal point? Well, this terminal point is going to have exactly the same x's and y's as pi over 3 did. Except we might have some negative values there. In fact, which one's going to be negative, x or y? X. So now we go back and we look at pi over 3. For pi over 3, our x was 1/2, our y was square root of 3 over 2. Exactly correct. So this is going to be negative 1/2 square root of 3 over 2 will be our terminal point. Okay. So basically what's going to happen in this class, we're going to memorize a whole bunch of facts about things in quadrant number 1. And if we have something in any other quadrant, what we're going to do is we're going to find the reference, and we'll use the reference numbers and just change our signs to be positives and negatives as we need them to be, depending on which quadrant we're in. Questions on that? All right, so let me draw another one for you. This time, my original arc is going to be in quadrant number 3. It's going to be right here. And that arc length happens to be 7 pi over 6. In this picture, where's my reference number? Now 7 pi over 6 is the original arc length. What would the reference number be? Not pi. Has something to do with pi, though. What's that? That minus pi. So to find the reference number, we always go from our point to the x-axis, to the closest spot on the x-axis. So this is our reference value right here. So if I'm in quadrant 3, I take and then I subtract pi. So notice the difference. When we were in quadrant 2, we took pi minus the original angle. When we're in quadrant 3, we take the original angle, 7 pi over 6, and subtract pi. What's 7 pi over 6 minus pi? How much? It's just pi over 6, because you can think of this as 7 pi over 6 minus 6 pi over 6. You get your common denominators and you subtract. You have 1 pi over 6. So our reference value is pi over 6. Now we can find this terminal point. We look at our chart. We look at our pi over 6. Pi over 6 had square root of 3 over 2 and 1/2. So what's going to be different down here in quadrant 3? They'll both be negative. So it'll be negative square root of 3 over 2 and negative 1/2. Questions on that?